Now we're ready to start building out our object pool. In essence, an object pool is simply going to be a class that manages instances that it creates. In the case of a pool, it'll also manage whether the objects are inactive or active. So whenever you request a new game object from the pool, it'll look through its list, see which ones have been already created but are not in use, and return one of those. If there aren't any inactive objects, it'll create a new one for you. Not all object pools dynamically scale like the one we're about to build. Sometimes you might want to have an object pool that has a set number of instances that it's allowed to create. This way, you don't come up with situations where you have a performance impact creating lots of new instances on the fly. But to keep things simple, we're going to just make a single object pool that'll always give you back an instance, either one that's already been created and not in use, or a new one from scratch. Let's go into our scripts folder and create a new C# script, and we'll call this object pool. Now our object pool is going to be attached to a game object, so we'll leave it extending mono behavior, but we will not need the start and update methods, so let's just delete those. Each object pool in our game is going to be responsible for a single type of game object. So let's create a reference to the prefab that it'll manage. We're going to make this public, and we're going to type this to our recycled game object. And let's call this prefab. Next, we're going to need a way of keeping track of all the instances that it creates. We're going to use a list. A list is very similar to an array, except you can dynamically add or remove items from the list versus an array, which usually has a fixed number of items, and once you create that fixed number, you can't modify the number inside of it. In order for us to use that, we're going to need to import some new classes. Let's copy the systems collection and paste it below. And at the end, we'll type out generic. This will give us access to a whole new type of collections, such as the list we'll be using, and dictionaries, which we'll talk about a little bit later on. Let's create a private dictionary. We'll make a list, and we're going to type it to recycled game object. We'll call this pool instances, and let's instantiate it. Here you'll see MonoDevelop is already auto-completing this for us, so we'll select the list that's typed to recycled game objects and close out the line. Now we're going to need two methods, one that'll allow us to create an instance when we need it, and the other that'll return an instance when we request it. Let's start with how we create instances. We're going to make our createInstance method private so other classes can't inadvertently ask the object pool to create one on the fly. The return type will be a recycled game object, and let's call this createInstance. We'll also want to pass in a vector3 representing the position of where we want to create the new instance. Now we'll create a clone of the prefab that the object pool manages, and this line is very important. Even though we have our game object utility that allows us to now create game objects, we are still going to use the default game object class's way of instantiating this particular game object. One of the reasons being, if the object pool asked the game object utility to instantiate a class, and the game object utility asked the object pool to create it, we would create a loop that would never get completed. So in this one case, let's pay special attention to use the game object instantiate method. This will be the only place in our game where we actually instantiate this directly instead of routing it through our utility. So let's use the game object static method to instantiate a new instance of the prefab. Next, we're going to want to set the position of the clone by changing its transform position and making it equal the position we supply in the method. Next, we want to make sure that any prefab instance we create is nested into the object pool game object in our hierarchy view. This will help clean things up when we're creating lots of different objects. In order to do this, we're going to tell the clone's transform parent to equal the game object's transform that our object pool is attached to. Finally, we'll need to add the clone to the pool instances list. Now we're ready to return a reference to the clone that we created. The last method we'll make is a public one to return the next object in the pool. Let's make this public. The object it will return will be a recycled game object, and we'll call this method nextObject. We'll also want to pass in a position so that we know where to create the next object. So let's set this as a vector3 and call this position. Inside, we're going to create a container variable to store the recycled game object we're going to create. Then for now, we're simply just going to create a new instance every time we request one from the object pool. Also, since we know that this is a recycled game object, whenever we create a new instance of it, we're going to want to call the restart method on it. And finally, let's return the instance. Now our object pool is ready. Next, we'll look at how to actually connect it up into our game.